Great. So once again, Josh Brothheim, training manager, and here we start with application observability with Sumo Logic. So the agenda for today is as such. We're going to be together for the next hour, and hopefully it's going to be an enjoyable hour for all of us. The agenda, introduction, which we're kind of already started, talking about observability with Sumo Logic. What do we mean by observability? What does the industry mean by observability? Then specifically using, although we might do these steps out of order, tracing. We're going to use a fun example with Sumo Logic Coffee. You may have seen this example before, but either way, it's still a fun example, and you will get some hands-on experience with the keyboard there. So do some work. We'll look at service maps, we'll look at traces, and then we'll talk about next steps. And that will take us to the top of the hour. So have a pretty full agenda for you, but I think you'll find it enjoyable. Let's see. Are you seeing video? You should see my screen. Can somebody just confirm they can see my agenda screen? Okay, good. All right, cool. Okay, perfect. Thank you guys. All right. Good. So let's keep going here. Oop, keep hitting the mouse too quickly. So this first slide, this is a slide you may have seen before. I still want to address it. It's an important one. And it's to give you an understanding of Sumo Logic as who we are. Hopefully you're familiar with Sumo Logic, but if you're not, that's fine. It's a good place to learn here today. But wanted to talk a little bit about what we do. And really focusing today on continuous intelligence, the platform. So as we've seen, and as you guys have seen probably as well, digital transformation requires continuous intelligence, and businesses are leveraging this new category of software, continuous intelligence, CI as it's referred to, which is going to help provide real-time analytics and insights from a single cloud-native platform across multiple use cases to speed decision-making and drive world-class customers. Using our analytics across operations, security, business, and global intelligence will help provide you that continuous awareness, which is going to impact your results. And on the top here, we have a couple different examples of where Sumo can help with. So for example, operational intelligence. Are your systems up and running? What is your MTTI and MTTR? Those mean time to identify and resolve those metrics that are more and more critical every day. Oops, sorry, I keep mousing out of this here. There we go. And so we're going to be talking about that a little more detail with operational intelligence, with tracing. We're going to start to see what's going on in your operations, and we'll give you some cool examples. Security intelligence is a great use case for Sumo to see who is using root access. Is a person logging in from multiple locations simultaneously, and has your SIM picked it up as an actionable item? Business intelligence, Sumo helps with showing what pages are people frequently viewing on your website. What are they ordering? If you ran a marketing campaign, was it successful? And then global intelligence, seeing how you're doing or how your organization is doing compared to other companies and observing your data worldwide. In the middle here with your data, what we're really stressing here is your data is going to come from a variety of different places. You may have data that's being generated by your apps, by your microservices, by your cloud systems, by your SaaS service, etc. And all these different systems are generating potentially large amounts of data, and Sumo can help you with that data. Essentially, you bring it in and then you can start to utilize it. We have built-in apps. We're not really going to look at the apps today too much, but they are an important feature and just worth plugging here. Those apps are going to give you some immediate functionality and really give you access to start querying and view dashboards about your data without putting in much legwork. Great, use the apps. I strongly encourage them. Let's see what else on here on this slide that's worth pointing out. For our analytics, they're going to be multi-tenancy. Information is very secure. Scalable elasticity, which is really going to help as well as you stand up or bring down your data. Machine learning is built in. Advanced analytics we might look at an advanced analytics feature today. APIs, of course, so that you can go ahead and utilize them to incorporate Sumo Logic into other products. On the right-hand side of the screen here, we want to just point out that we have our variety of different security certifications and attestations, PCI, SOC 2, HIPAA, you see some of them there. And most recently, or fairly recently, FedRAMP moderate, which is quite a big deal for us, and yeah, just for us. If you've ever gone through getting FedRAMP approval, which I've done a few times now, it's quite a headache. So it was a great milestone for us. And then finally, who can benefit from Sumo Logic? Well, your people can, regardless of what role they're in. If they're in DevOps, if they're in SecOps, if they're in customer success, or in between, those people can benefit from Sumo Logic, because you're using Sumo as kind of a single pane of glass, if you will, through which to view your data, your environments. So a little update of who we are. And now let's get into end-to-end observability with Sumo Logic. So now you know a little bit about Sumo Logic. Now let's start to talk about the observability side of things. So this slide I put together, I thought it was helpful. I still do think it's helpful. What I'm trying to show here is the difference between monitoring and observability. And I wanted to do so just so we're all on the same page with terminology. Now, a lot of people equate observability to monitoring, and that's not incorrect. There's, of course, a relationship between the two. But as we dig deeper, we're going to see that monitoring is about just seeing when something goes wrong. But what we can do with observability is start to see what's causing it, what areas it's impacting, and how can we correct it before it impacts more customers, more parts of the application. So how is observability different from monitoring? Monitoring is about telling you the state of a system by looking at parts that have been configured to be monitored. If a part of the system isn't monitored, then we have no idea what's happening there. And knowing something is wrong is sort of important. Observability goes beyond monitoring. By bringing together those logs, those metrics, those traces to give us a broader view and a deeper context, knowing something is wrong, but also being able to find out why. So like I said, just thought it was important for language or definitions. All right, my iceberg slide here. So let me get this one loaded. What we're showing here is, as we have defined observability, as we want to get deeper into the root cause and understanding what's gone wrong, we need more data. So I'm just going to load this one entirely just so we get the full picture of it here. So what we're showing here is an iceberg, and at the tip of the iceberg is that what? That monitoring that we just talked about. An important feature of Sumo and important for you in general, but it's just the tip of the iceberg. It's not going any deeper. Now, to see the what, we approximate that you need about 20% of your data. But an observability solution should be able to handle large-scale data sets. While monitoring and diagnosing require working with some amount of data, as we say here, about 20%, it's the troubleshooting phases where the observability system should really be able to handle unlimited amounts of data from logs, metrics, and traces. And this is a challenge for many observable solutions that don't have a high-end, highly scalable solution. Well, fortunately, built on a cloud-native architecture, Sumo Logic enables you to ingest and store any amount of data in a highly elastic and flexible way. Secondly, the observability solution also needs to have a very scalable analytics engine. Observability requires you to analyze lots of data to machine learning and other search-driven analytic capabilities. As a large-scale machine data analytics platform, Sumo Logic provides out-of-the-box capabilities to support the ingestion and analytics of any amount of data. And so that's what we're trying to show here is, as you go deeper into the story, if you will, or what has gone wrong, or more importantly, the why and the how and the where, more data is going to be required, and Sumo can handle it. And there's that more data required. All right, a similar slide. We have a few here that take a similar theme of the monitoring, diagnosing, and troubleshooting. But in this case, what we want to point out is that in order to achieve end-to-end reliability, that unified observability platform is going to be necessary. So what does that mean, especially related to this diagram? Well, on the left-hand side of the screen, what we see here and what we're trying to show here is that it's required to get all bits of data telemetry to perform the tasks that teams who are in charge of reliability, DevOps, DevSecOps, from each and every layer that affects the application. Basically, your data is out there. It could be coming from hosts, your servers, your Kubernetes clusters, could be coming from your CI/CD pipeline, load balancers, and 100 million other places. And that data will come into Sumo Logic. Once you have all relevant data that's required, such as those metrics, metadata, logs, and traces in your Sumo Logic platform for visibility, then you can start to go a little bit deeper. You can start to monitor those alerts or configure those alerts so that it will let you know what is happening. You can utilize the diagnostics through trace spans, and we're going to look at that as an example shortly. Then you can go even deeper in step 3 and start to troubleshoot using root cause analysis, which is just another tool that we have. And I think I'll go over today. I can't remember if it's in this presentation or not. But so that's what we're showing here is as the data gets in there, then you can start to monitor, but then you can go deeper in that observability of starting to diagnose and troubleshoot, which is going to give you great insight to your environments. Another variation on this similar theme of the slides is the fact that who in your organization can gain value from observability? Well, the simple answer is everybody, but to be more specific, for example, DevOps and SER teams, those individuals that are responsible for monitoring the health of an application, they are going to need observability so that they can quickly monitor, diagnose, and troubleshoot application health issues. Who else can observability help? The software engineers. So observability is going to help them by providing visibility into the software pipeline. By collecting information about the software pipeline and identifying issues with the delivery process, teams can improve the quality as well as the delivery of their applications. And then finally, DevSecOps. Observability is going to help security teams ensure the security posture of their applications. Now, what's unique about the Sumo Logic observability solution is it addresses the needs of all these teams and personas in one integrated platform. And of course, there's more teams that can benefit from observability, but there's a good chance that you probably fit into one of these roles. So we have 47 individuals. I'm going to assume about 40 of you fit into one of these groups. If you don't, that's fine as well, but it gives you a feel for how observability helps. All right, a couple more slides, and then we'll get into a more fun example. This is essentially a rehash of the other slides we've seen, intentionally so, but what we're showing once again on the left-hand side of the screen is monitoring, diagnosing, and troubleshooting, and trying to really drive those into your head. And then what we're showing here in the middle part of the screen is the level of detail that you can access or get to based on which step you're at. So with monitoring, the system is going to provide you some basic charts and graphs that you will create or the system can create, but that's going to give you some basic charts, some basic graphs, some basic email alerts to let you know that the system is up or down or what's going on. But as we dig deeper and want to dig deeper into the deployments, into clusters, and looking at transactions, we're going to start to diagnose and ultimately troubleshoot. And accordingly, we're going to use the tools that are appropriate with that. So with the diagnosing, we're going to look at tracing, and we're going to look at that about 30 seconds. And then with the troubleshooting, we're going to utilize root cause. And we're not going to go through Root Cause Explorer too much today. We're really focusing on this diagnostic step. All right, let's see, one more slide. This is a quote that I think is funny or relevant. Some people at Sumo don't have my same humor. It's not that funny. But what it says is we replaced our monolith with microservices so that every outage could be more like a murder mystery. And what this is an alluding to is Sumo Logic observability, or observability in general, but I guess more specifically Sumo Logic. And you start to use that observability to determine, like a murder mystery, who done it, where, and why. So it no longer is just something has gone down. It's now like the old board game Clue of Professor Mustard was in the observatory with the wrench and starting to give you those specifics, which is really going to be an asset. Well, probably one of the reasons you're here is to see how observability can help you. And it's going to give you that deeper insight into what's going on and why it's happening and where it's happening and how it's happening. So not just the what, but the other WHs, where, what, why, and how. All right, going to keep going here. If there's any questions, of course, put them in the chat. Yeah, but I'll keep going here. Now we want to talk about tracing and Sumo Logic Coffee. Now, Sumo Logic Coffee, you're probably familiar with. We are world renowned for our coffee. We are have thousands of locations around the world. Of course, we don't, but for today's example, we will. But imagine that we are very similar to another company out there that has a green logo. For copyright reasons, we couldn't use it, so now we're using Sumo Logic Coffee. And our goal at Sumo Logic Coffee is to give you or the customer a hot, fast cup of coffee. That's priority number one. Now, how are we going to start to use computers and Sumo Logic and technology for delivering a cup of coffee? Well, let's explore. When you go to order a cup of coffee, it sounds like a very straightforward, hey, give me a cup of coffee, pay for it, and you have your cup of coffee. It's a little more detailed than that. And so these are some of the steps that take place. The customer is going to place their order, probably using our Sumo Logic app, but for today, let's assume we have one. But either way, they're going to place their order maybe directly at the store. The order is going to post to the barista. So the barista is going to get that order, and then he or she is going to get that coffee machine running. They're going to initiate the coffee machine. And the coffee machine is going to do a lot of the heavy work. It's going to make sure it has an adequate amount of ingredients and then grind those ingredients, or those beans more specifically. It's going to make sure it has an appropriate amount of water to create that cup of coffee. And then it's going to add that water to the coffee to produce coffee. It's going to do its magic, and then that coffee is going to be ready for the customer. Now, unfortunately, at Sumo Logic, we are Sumo Logic Coffee. We are not we are a for-profit organization. Our goal is to make money, and so the customer is going to have to pay for that order. Now, the credit card, we're going to assume this is using a credit card or a non-cash transaction. A credit card is going to need to be approved. Once that card is approved, then the customer can pick up their order. And in those respect, or in respect to those steps, it's like each step is a microservice. The customer places the order, that's one service or step. Orders posted, another one, and so on and so forth. And what we're going to do is start to use Sumo Logic to look at these orders, look at these transactions, and see if things have gone wrong and why. So here's a quick review of similar as I was describing, but starting to get into the systems that are going to take place. So here we have Abel. He's a coffee lover, and he's a frequent visitor of Sumo Logic Coffee. And he places his order on the coffee app. Now, what happens when he places his order in the coffee app? The order is going to go to Sumo Logic Coffee, and the barista, as described, is going to start to initiate that coffee machine. Now, when that occurs, machine service is going to need to be activated. The service that is responsible for the coffee service, the service that's responsible for the water. On the other side of the house, although still within Sumo Logic Coffee, is the payment side of things. Once again, we don't give free cups of coffee, so there's a payment system, a calculator service that's going to be used to calculate the cost of the coffee. The SQL records that are going to be used to store the different prices for the different offerings we have. A cup of espresso and a cup of decaf are going to be different prices, and those will be reflected in a database somewhere. And so these are all the different areas that are going to be touched when that coffee is produced. And so now it's going from a simple cup of coffee to multiple services running in the background. Still simple-ish, but that's what's starting to take place here. Now here we see, and similar kind of covering along the same trend, even the simplest three-tier applications such as Sumo Logic Coffee is going to require a load balancer, a couple servers, a database, and I just alluded to some of that already. What we need here, though, is a view into the app's environment. And so what we're going to talk about now is some of those views. The first view I'm going to talk about is a service map. And this is an example of one right here. We'll see one hands-on shortly. We're getting to that hands-on portion, a couple more slides till we get there. But this is what the service map looks like. What it is, as it says in bullets here, it's a high-level view of your application environment. So what we see here is the Coffee Bar app, which this is the application that's used to order coffee. And we start to see those services as starting to describe. So the image is moving, but we see the coffee bar, we see the coffee machine. The coffee machine is going to go to the machine service. We're then going to go to the water service and the coffee service for those two specific features of coffee. On the right-hand side here, we see the cash desk and those calculator service, that SQL account that I was referring to. This, as it says, automatically built from tracing data in real time, and the goal is to give a greater understanding. And so in real time, what we're starting to see are red representing an issue. When we mouse over it, we start to see it's an issue with latency, and we'll dig into shortly what that might mean, but we're starting to get some insight into our environment. Quite helpful. Traces by service. This we're going to look at and play with very soon. We're getting closer to that lab every minute. But this is what this traces by service looks like. So what this screen is showing is for whatever criteria, the trace ID. So this is the, I guess it's not the transaction ID, it's the trace ID, but it's similar in that it's an ID that you can utilize to locate a specific order. We see the duration. So this is represented, this column right here for duration is the time that the order took. At Sumo Logic Coffee, we deliver that fast, hot cup of coffee. And so time is important. Is an order going to take a second, a minute, an hour? Well, those are going to be important to somebody. Those kind of those milestones that are hit. Here we have a duration breakdown, this colored bar. We're going to look at this much more specifically and zoom in on this very shortly, but we do start to get a visual here of which services were taking different amounts of time. So for example, if I remember correctly, green is the actually I don't remember them. We'll look at them in a moment, but we're starting to get that visual, which is helpful. And then we have our status codes, and we're going to use those status codes to help us track what has gone wrong. And we'll use those just in a moment. So really getting close to those labs. All right, I think one more slide before the labs. And this is an individual traces by trace ID. So what we're seeing here, and hopefully you can see it okay, it will be zoomed in when we get into the app. But what we see here on the top is a representation of a successful transaction. We know it's a successful transaction from this 200 on the top of the screen. It's a status code that indicates that it was successful. And what we see here is, as I've been trying to describe, we see those services, that green representing cash desk, that purple, I don't know, fuchsia, that represents the coffee bar, this maroon that represents the coffee machine, and so on and so forth. And then down below, we start to see those services broken out. And we're going to start to look at these more specifically, but we're starting to see them down here. Now, here's an example of a transaction that was not successful. It looks similar in that the view is the same, but there's a few things that are different. The major things that are different are these horizontal red lines. What these horizontal red lines are indicating is that there is an error. Specifically, we're going to look at the lowest level where the red line occurs to give us an indication of where that error has occurred. And here we see it's in the blue, and we'll look at that blue in a few moments in the lab together. The other indication that we see that something has gone wrong is the status code of a 503. If it was a status code of a 200, that would mean it was successful and everything was good. It isn't a status code of 200, and that automatically means something is not quite right. Now, what does a 503 mean? Well, we're going to figure that out together in a few moments, but this is where we're kind of driving to. All right, so let's get into the labs now. So let's just dive in here. So let me share the set of credentials that we're going to use today. We're going to use, actually, it doesn't really matter which one, they're both the same. Let's go ahead and use these. Let me go ahead and put them in the chat. And so you're going to go to service.sumologic.com, which hopefully you're familiar with. If you're not, well, welcome. And you're going to use the email address or the user account of training plus analyst number, and you are going to select a 3-digit number. So maybe you want to be training analyst 123 at sumologic.com, 278, training analyst 007 at sumologic.com. Pick a 3-digit number and then utilize that password of Sumo Summer 21 exclamation point. So capital SUMO, capital SUMMER, 21 exclamation point. Go ahead and log in. If somebody can just confirm they logged in, just so I know we're kind of together, that'll be helpful. Good. All right. A few of you. Good. Take a few moments. Well, a little bit of a rush, but no major rush. If you can't log in or don't want to log in, that's fine. We're going to be doing the labs together. So you'll see them on my screen. You'll still benefit. So certainly we encourage you to log in, but like I said, if you don't want to or can't, that's fine. Just going to kind of tap dance here just for another moment, just to let those stragglers get in. And as a reminder also with these credentials, this is a training environment. Don't put anything proprietary in there. It gets deleted periodically. Yeah, those are really kind of the big warning points. All right, so now we should be logged in. If you need help getting logged in, don't be shy. I know I'm kind of getting us going here, but if I need to take a step back, please let me know. All right, now that we're logged in, actually, let me log in. I'm sorry. That's what I should have been doing. I might still be. Okay, cool. I'm still logged in. What we want to do here is we want to go ahead and look at the service maps. And so to get to the service map, what we're going to do is we're going to go to New and Service Map. I'm not really creative here in Sumo. So we're going to go to the home screen. You should be on the home screen automatically. Hopefully you've seen the home screen before. If you haven't, that's fine, I guess, but you're certainly seeing it now. And what we want to do is we want to go to plus new and go to service map. You can also do Alt plus I if you want to use a keyboard shortcut, but plus new service map. And what we see here is the service map. Now, what we can do here, and I'd encourage us to do this, is we have the ability to filter our data. In that right now, we're looking at all the different data within this training account. But we can specifically say, just show us the Coffee Bar app data, because in this case, we're Coffee Bar employees, and we want to just associate with the Coffee Bar app. So I'm going to select the Coffee Bar app. All it's going to do is just remove that other data that was there and just focus on the Coffee Bar app. And what we're seeing here is that visual that we saw on this slide. And so go ahead and feel free to kind of poke around here. But what we're seeing in real time is issues. Blue in the bottom left, we have our legend. Blue is normal, but red is an anomaly. So this is letting us know that currently, or over the last 72 hours, but this part is really just in the last 15 minutes, things are anomalous, specifically latency. So as we start to mouse over these, we see latency is in red, and it's actually telling us it's over normal, specifically 45% over normal. So latency is bad. I don't think I'm making a radical statement there. And certainly when we're delivering a hot cup of coffee, we want to know about latency. We want to get it out fast. If it's latency, that's delaying things, and that's causing us not to get that coffee out as quickly. And so that's what this service map is showing us. We can start to click on some of these items to see some more details. But this is showing us in real time what's going on or not going on, as the case may be. Another portion of this service map settings that I want to point out, let me just get rid of that portion, is this gear icon on the top right, sort of, that says settings. What this allows you to do is start to modify the anomaly detection. So by default, the system is determining if something is an anomaly using outliers and other math and stuff. Stuff's not the proper technical term, but using math to determine it. What you can do is you can modify that anomaly detection. So maybe you want to do it based on a KPI of latency. Maybe you want to modify the outlier threshold. You can do so. We don't really go much deeper in the fine tuning of these, although they're pretty basic in that you modify a value and then you see the graph change in some way. But outliers are a really important feature of Sumo Logic. We don't really go much deeper today, but in many other classes we do. It's a great way to have the system determine what is normal and what isn't, rather than you doing it. So I wanted to show service maps as a cool new feature. This feature launched, I don't know, a couple months ago. It's been pretty well received. All right, let me get back to my deck here just to make sure I'm up to date. So we went over service map settings. Now what we want to do is do traces, specifically a walkthrough of tracing. Now I showed you the chart, but we want to go ahead and get a little bit deeper. So what we're going to do here, actually, I'm just going to, just thinking if you need to follow these steps. Let's do it on screen. So we're logged in still, hopefully. And now what we want to do is go to plus new and select traces. Now when we do, we get the screen that I was showing earlier. What I want us to do here, it's not, I think I want us to do it, is I want us to filter. The filter I want us to use, let me see if I still have the text version of it. No, I don't. Oh, here it is. Let me paste this into the chat for you guys. This will make it a little bit easier. Apologize if I'm jumping around a little bit. Just want to make this as seamless as possible. What I want to do here is I want to select the filter, because right now I'm looking at the root service for a bunch of different data in our system. This is a training environment. We have our coffee data. We also have payment data. We have other stuff in here. And I want to say, just show me coffee lover stuff. That's the internal name for our company or our application. So just show me service equals the coffee lover. I don't want to see any other stuff. The screen is going to be basically the same, just cleaned up a tad. And then as we see, and as I was starting to describe, we see that trace ID, which is not the transaction ID, but in Sumo it is. We see that root service, the coffee lover. We see started at, so when was the order placed? We see the duration. In this case, it's in milliseconds. We are very quick in delivering a cup of coffee, but we do have a way to see how slow or fast we are. We have this duration that I was trying to describe, and having the mouse over gives it a much easier explanation. But what we see are the different components of that transaction and a visual with the time and a percentage breakout for each service. So starting to give us a view into that transaction, but still looking at the traces, not even going into it yet, but at the surface level, we're still getting potentially a good idea of what has gone on. And then we see the status codes over here. What I'm going to do here is I'm going to click on the status column, just so I can go ahead and sort these status codes. And what I want to do first, and I showed this in a screenshot, but now I want to show it to you hands-on, is one of these status codes, one of these traces, excuse me. So what I want to do is I want to select a 200 status code. Doesn't matter which one, because they all should be successful transactions, but I just want to pick one. And so pick one, doesn't matter which one. What you see when you get in here is, as I showed earlier on the screenshot, is those services, the duration, the percentage, and then down below, we start to see those operations of those services, those portions that are actually doing the thing. So for example, here, cash desk is represented in green. And what we see here is green representing some of those features of that transaction for the payment portion. The coffee machine is represented in maroon. So what we see over here are the steps that are used to put together a cup of coffee. So this is an example of a successful transaction. Let me go back to my slides. What we're going to do, though, is we're going to utilize those status codes to get to the root of a problem. And this is a bit of a pun, not a very funny one at all, but this image will become a little more relevant because we're going to use the roots, or tree structure, roots. Yeah, it's trying to be funny. So let's go ahead and look at let's do some hands-on exercises together. So what I want us to do, we can just actually skip this. We can go back to the traces. And if we scroll down the status column, or just scroll down period, we're going to see that there are a couple different status codes. We want to look at some of these status codes, and what we want to do together and in the lab, but first we'll do it together, is start to determine what has gone wrong through a status code. So what I want us to do to start with is I want us to select scroll down in the status codes and select a status code with a 503. Doesn't matter which one, but find one that has a 503 and click on it. When you click on it, it's going to be similar to the screen I just showed you, but different in that it has red and it's referring to 8 error spans, referring to the fact that something's not quite right here. Now, how do we figure out what's gone wrong here? Well, we're going to go ahead and utilize the tracing aspects. We're going to go ahead and look for the horizontal red line, which is indicating an error. And we're going to go and look for the lowest level where the red line occurs. So up here, this is showing us that there was a problem. As we get further down, though, we're getting more granular of locating that problem or that issue. And what I want us to focus on specifically is this blue box here that has a red horizontal line. It should if you chose a 503. When I mouse over it, it's starting to give me an indication of what this thing is, where this error has occurred. This is the service for water service, the operation getting water. So something has gone wrong with the water. Now, what specifically has gone wrong with the water? Well, let's find out. I'm going to go ahead and click on this blue box. And when I do, there should be a panel kind of thing that pops up on the right-hand side of the screen. It's showing some information about the operation, the time, the status, some other stuff. But what we can figure out here is we can open up our logs and start to try and figure out, not try and figure out, we will figure out what has gone wrong here. So what we're going to do is we're going to open the logs tagged with, we can use the span ID or the trace ID. I'm going to use the span ID for right now. So I'm going to click on span ID and encourage you to do so. And what we should see here is an indication of what has gone wrong. These messages are going to be in reverse chronological order. So the more recent one will be at the top. So at the very bottom, if we look, we start to see what went wrong. Info, received order for water in an amount of 3 milliliters. The cup of coffee that the person ordered needed 3 milliliters of water. Error, not enough water. The system just didn't have enough water in it. And so what we now know is a 503 indicates that there was not enough water in the system. We can confirm that if you don't believe me, and that's fine. You can go ahead and select another 503. Do the same steps, but ultimately you're going to get the same cause. And so what we now see is those 503s mean there's not enough water. Now, what do we do about that? Well, I don't know. We might do many different things. We might train our baristas to check the water levels more frequently. We might add a bigger water reservoir to our coffee machine. There are many ways to approach it, but now we're getting that observability to see what has gone wrong. Now let's go ahead and look at a different status code and try to figure out what's gone wrong. And we'll do this one together. Let's pick up 502. So we're going to select one of the 502s. And we're going to continue that process of looking for the red line at the lowest level. Now this time we see the red line is still associated with this espresso preparing the coffee, but this time the red line is not on the blue, it's on the brown. If we mouse on the brown, we start to see some indication of where or what this issue is related to. It's related to the coffee service, specifically getting coffee. You might be able to predict what has gone wrong here, but let's verify if you're right or not. We're going to click on the span ID. And in reverse chronological order, we're going to see info, received order for coffee grains. 1 coffee grain was needed. Error, lack of coffee grains. The system didn't have enough coffee grains in it. Once again, we might want to create a bigger coffee bin or have our baristas refill it more frequently or whatever, but the system is now telling us what's gone wrong here. And now we know what a 502 is. If we go back to our traces and look at any of the 502s, we're going to get that same result of not enough coffee. All right, so what I want us to do now, or want you to do now, is look at a 402. So take one of the 402s and I want you to figure out what has gone wrong and let me know in the chat. And I'll give you a moment or two and then I'll show you. Won't spend too long on it, but I want you to go ahead and see if you can figure it out. So giving you a moment, kind of tap dancing a little bit here. So we're going to figure out what a 402 means. All right, let's go ahead and go through it. So I'm going to select one of the 402s from my traces, doesn't matter which one. I'm going to notice that it's bad, it's red, so that's not good. But with the red, I noticed this time that it's not related to the coffee machine here. There's no red related to the blue or the brown or whatever color that is. Instead, I see a red horizontal line over here with the green. So this is right away letting me know that there's an issue with the cache desk. Now, what specifically with the cache desk has gone wrong? Well, let's figure it out. We're going to go to the lowest level where there's red, and we're going to click on it. And then we're going to select that span ID. We're going to scroll to the very bottom, and here is our story of what has gone wrong. Here we see payment in progress. So the person placed an order. The system is getting the product price. It's starting to query the database for that price. So checking is a cup of espresso, how much? The system is calculating that total price for espresso. And then the calculation result is provided. And then this person needs to pay for that cup of coffee. Well, here's what's gone wrong. Error, not enough money. The user didn't have enough money on their credit card or their gift card or whatever method of payment they were using. And so now we know that indication. Now we know a 402 is equal to payment issues, credit card declined essentially. And so now we have that insight, which is pretty cool. All right, so hopefully everybody was following along there. Any questions? Okay, let's more to show here. Let's see. Well, let's go back to the slide just to level set again. So we went through the error cheat sheet, what it was as discussed. That 402 was a cache desk issue. Our web payment interface was down or card was denied or something like that. All right. Here's the question. In real life, could one error code cause multiple errors? Absolutely. So yes, I guess is the short answer. I don't have an example of one, but yes, it could. All right, tracing apps. I think I I talked about apps. I talked about the benefit of them, and a little bit of a surprise to me, we're going to show them as well. So hopefully you're familiar with the importance of apps in Sumo Logic. I really hope so. It's a really one of the better, well, the many benefits